In this video, this is lecture number 4, mass spectrum of an element, AP chemistry. So what does mass spectrum of an element tells us? It tells us about the mass and relative abundance of each isotope of an element which is present in the sample. And we can determine it with the mass spectrum. So mass spectrum. So first of all, what is an isotope? Isotopes are the atom of an element having same atomic number but different atomic mass. Have same atomic number but different atomic mass. Like for example, we have 3 isotopes of hydrogen, that is H11, H12 and H13. This is called as protium, this is called as deuterium, and this is called as tritium. You can see it has electron 1, proton 1 and neutron is 0. Here we have electron 1, proton 1 and neutrons are 1. Here we have electron 1, proton 1 and neutrons are 2. So you can see these are the isotopes having same atomic number but different atomic mass, having same number of electrons and protons but different number of neutrons. If you can take the example of chlorine 1735 and chlorine 1737. So you are going to see that this one is having electron 17, proton 17 and neutrons are 18 there. Electron 17, proton 17 but neutrons are 20. So these are basically the isotopes of chlorine, and now we are going to discuss about mass spectrum. So if you can see, this is basically the mass spectrum of chlorine 1735 and chlorine 1737. If you can see on x-axis, this is x-axis and it represents basically mass to charge ratio, and this is y-axis which basically represent relative abundance. If you can see chlorine 35, that has the relative abundance of 75%. If you see chlorine 37, that has the relative abundance of 25%. If we want to find out average atomic mass, then what we need to do, we are going to use this formula that I am going to multiply the average the atomic mass of isotope chlorine 1735 with the percentage, and then plus I'm going to multiply 37 with 25, which is the percentage abundance of chlorine 37. Then I am going to divide it with 100. So the answer comes out to be 35.5. So this is basically the way how to find the average atomic mass. Now there is a worked example, and they have drawn a structure of mass spectrum, and you can see that they have different values and they want us to identify that which element it is going to be. So first of all, let's mention its atomic masses. So if we are going to see the elements. So first of all, let's identify which element it is going to be. So first of all, we must know that the average atomic mass of the element should be between the highest abundance and the lowest abundance. So this is the lowest one, like this is the highest abundance, and it is going to have the 64 atomic mass, and this is the lowest abundance, that is 70. So the average atomic mass should lie between these values. So if we see about copper, it is 63.55, which is less than 64. So this could not be the answer. Okay. And if we see nickel, nickel is 58.69, which is out of this range. So this would also not be the answer. If we see gallium, gallium is 69.72, which is closest to the lowest abundance. Its value should be closer to 64, which has the highest value. So this one would also be not be the answer. But zinc should be the correct answer. Its value is 65.38, which is closest to the highest abundance. Like this is the highest abundance, and this is the highest abundance. So our answer would be zinc. So now if we want to find out the average, like they have given us the average atomic mass, you can see here, and they want us to find the percentage abundance of each one of them. So we know that if we can take the percentage abundance of this one to be x and this one to be y, and their sum is equal to 100, and if we can keep it in the form of x only, then you know that x is there. But if we want to find out, like we can write y in terms of x, we can keep 100 minus x. So we can keep y is equal to 100 minus x. So in order to apply the formula, we know average atomic mass, we are going to write here 10.81. That is equal to, boron 10 is 10.01. I'm going to multiply it with x with its abundance, plus 11.01, that is boron 11, and I'm going to multiply it with 100 minus x and divided it with 100. Now what we can do, we can take 100 over there, so multiply 100 with it, it would become 1081, and this is 10.01 x plus 11.01 into 100, that becomes 1101 minus 111.01 x. And now we can solve them, and 1081 minus 1081, I am going to take 1101 on the other side, and then solve this part. So it would become 10.01 minus 11.01, and it comes out to be minus 1, that is minus 1x, and this part would become 1081 minus 1101, so it would become minus 20. So is equal to minus x, and that would cancel out, so x becomes equal to 20. So its abundance is 20. By putting the value of x here, so 100 minus x, that would become 80. The question says that an element consists of two isotopes X69 and X71 whose abundance are 60% and 40% respectively. What is the relative atomic mass of element X? So in order to find out the relative atomic mass, we are going to use the same formula which we have discussed before, that is the average atomic mass times with its relative abundance. So this is going to be 60%. 69 has 60%, and 71 is the mass of the abundance 40% and divided it with 100. So we can calculate it and the answer comes out to be 69.8, which is B. So now there is the mass spectrum of element X. So they have given us some option and they say what is true. So element X is germanium. First of all, germanium has the relative atomic mass of 72.6, which is not possible because the atomic mass, average atomic mass must need to lie between 70 and 72. Then they say X has a relative atomic mass between 71 and 72, but the second most abundant peak is of 71. So the value should lie between 70 and 71 because they have the most abundance over there. So this cannot be true. This can also not be true. The most abundant element of isotope X contains a total of 71 proton and neutron. This is absolutely right. Why? Because this is the most abundant peak. And its atomic mass is 71, which is basically the sum of protons and neutrons. So the value comes out to be C. They say that in D part the spectrum shows the abundance of the isotope 72X is greater than the abundance of 70X. No, it's not possible because 70 has the less abundance, 72 has the less abundance as compared to the 70. So this option would also not be true. In question number 2, they say element Z has 3 isotope and they're naturally with abundance of 24.4%, 32.4% and 43.2% respectively. So we need to find their average atomic mass. So in order to find average atomic mass, what we need to do, I'm going to multiply the 70, which is the atomic mass, with its abundance 24.4 plus 72 times 32.4 plus 74 times 43.2 and divide it with 100. So the answer comes out to be 72.38, which is going to be A. So question number 3 says a sample of neon contains the isotope neon 20 and neon 21 and their average atomic mass is 20.2. What is the percentage of 21 neon? So we must know, we can like suppose its percentage abundance to be X and its percentage abundance to be Y and their sum is equal to 100. And we can keep y is equal to 100 minus x so that we can keep the abundance in terms of x. So let's put them in the formula. We know average atomic mass is equal to 20 is the atomic mass times with x plus we have 21 times it with 100 minus x and we are going to divide it with 100. So let's put 100 over there. It is going to multiply, so it would become 2020 and then we have 20x plus 2100 minus 21x. So we can take 2100 over there, so it would become 2020 minus 2100, which is equal to minus x, and this comes out to be minus 80 is equal to minus x and x is equal to 80. And they want us to find for 21, which is y. Then y comes out to be 100 minus 80, that becomes 20. So the answer is going to be B. So in this question, we need to do the estimation, and iron has many different naturally occurring isotopes. They are the different isotopes which have different isotopic mass, and the most abundance, we need to see the most abundance is of this one, and that has the isotopic mass of 55.93. Then average atomic mass of iron should be near to that, and if we see the option D, that is closest to the most abundant element, so the answer D is the right one.